11, right, it says calculate the coordinates of the point on the curve at which the derivative is equal to 0. Okay, so you're given this equation for the curve. So since you're given that the derivative is equal to 0, we will first find out what is the derivative. Okay, so actually this one, you will re-express it to the power 4 first, so 1 over 3. Okay, so the derivative itself, bring down the power minus 1, then differentiate the inside, right? Okay, and then you will get this derivative. Okay, then after that, since we're told that the derivative is equal to 0, so this is equal to 0. Okay, so if I were to re-express it into an algebraic fraction, okay, this will be what I'll get. Okay, so in this case, the denominator, okay, surely it can't be equal to 0. So we can multiply the denominator over to the left hand side, okay, such that the numerator will be equal to 0. So x will be equals to 1. Then when x equals to 1, since you're trying to find the coordinates, we substitute it back into the given equation. So that will be 4 to the power 1/3. Or in other words, if you want to write it in this form also okay. So the coordinates would be 1 and cube root of 4. Okay, come in. Alright, any questions? Okay, right. Okay, if no problems, then could you please submit your homework to the front? Yes. How do I get 2x minus 2? Because this is equal to 0.
So you just bring that out.
I multiply here to left hand side, then 0. Denominator surely can't be 0.
Miss Tan,
Yeah.
can I hand out 2B, 2C, then all the homework like on Wednesday?
Wednesday.
Yeah.
Okay, but Wednesday, that's tomorrow, you know.
Thursday, sorry.
Why you got CCA?
Huh? Never mind, I almost died already.
I don't want to collect cops, you know, in my class. Okay, pass your homework to the front, please. Okay. And then today we'll start with new chapter.
New chapter?
So this my one portion will finish already, what? So still one more portion. Yeah, but I thought not in future. Yeah. Because it's the same routine again, this kind of thing. Yesterday you started on 14.4, then you finish 14.4. It's just portion rule. Oh,
This new chapter already ah?
yes.
One week, one chapter leh. One week, one.
Oh yeah, you all wanted the schedule, right? The flow of our lessons for this year. Okay. By the way, you are expected to actually have one chapter on A Maths, right, to be covered in June holidays. Okay. So I'm not sure whether it will be in week 1 of June holidays or will it be in week 4. Based on the last information I understand is that the Sec 4s will come back for remedial or lessons or whatsoever in week 4 of holidays. Yeah. As per previous year, the activities is always 1 and 2, right? Okay. But this year it has been changed to week 1 and week 4. Yeah. So I'm just telling you in advance, okay, in case your parents are starting to book any holidays and all that. Okay, so don't book in week 1 and week 4 of the June holidays. Right? Okay. First and last week.
I book in the middle of
Why not just before June holidays what? Mother tongue intensive is before June holiday.
You didn't get mother tongue.
Your mother tongue O level is June holiday week 1 eh.
Oh, really?
O level of Chinese is third June, right?
Oh shit.
No, you can
That's a 6 months or 7 months.
4 months.
It was just get mother tongue extension last year. We take harder. Then go to retake paper. Then you since you wanted it, you submit to double copy. It's okay.
Okay, let's start on chapter 15. Okay, can we start? Okay, chapter 15, we're going to be looking at tangents, normals, and rates of change. Right, some form of application. Basically, we're moving into the applications of differentiation. Okay, so we will first be looking at the equations of tangents and normals. Okay, we have covered tangents and normals last year. Do you all still remember what is a normal? It is perpendicular to the tangent, right? So if we have a curve like that, okay, at this particular point we can have a tangent. Okay, sorry, my tangent may not be very good. So this line itself will be the tangent, and we have learned earlier in the chapter 14, right? Okay, if you were to have some equation for the curve, okay, y equals to something, okay, the gradient of the tangent will be equals to dy over dx, right? Okay, this is what we have covered. And then, based on what we learned last year about normals, normals are perpendicular to the tangent. So this will mean that the gradient itself, what will the gradient of the normal be? How is it related to the tangent? It is negative 1 over the gradient of tangent, right? Okay, so this was what we have learned about tangents and normals. So today we are going to look at the derivative itself. Okay, so then also last year we have covered, okay, what is the equation of a straight line. Okay, Emax we have covered y equals mx plus c. Okay, then Amax we learned another formula, right? So if we have at a particular point, okay, x1, y1 for example, okay, we know it's y minus y1 equals to the gradient m times x minus x1. Okay, whereby m is the gradient that we're referring to. Okay, so these are all things that we have covered last year. Okay, then after this year we just put in the information, the idea about differentiation. What's the y-intercept over here? You just have to expand, simplify, then into that form. Okay, so let's look at try 1. Okay, we are looking at a curve with this equation, and then it says that there is a tangent and a normal drawn to this curve at x equals to negative 1. Yeah.
So the gradient is for the tangent, then the
This one?
tangent.
Yeah, gradient for tangent.
Then the bottom one is what?
Gradient for normal. Okay, so we want to first find out what's the equation of the tangent and then the equation of the normal.
I know what you want.
Okay, so since we know that the gradient will require the derivative, so we will differentiate the equation of the curve. That will give you 3x squared plus 6. Okay, Then after we want to find the exact gradient, right, at the exact point x equals to -1. So at x equals to -1, we will substitute in the value of x, and then after that, that will give us a gradient of 9. Okay. Then in order to have our equation, right, we always need the gradient and also one point, okay, the coordinates of one point that passes through that particular line. Okay, so now since we have only the x coordinate, we also need to find out what's the y coordinate. So the y coordinate would be, if I substitute in x equals -1 into the equation, that will give me the value of -4. Okay. So now that I have the point, the coordinates of the point and also the gradient, I can form my equation. So therefore, equation of the tangent y minus y1 equals to gradient times x minus x1. So the equation will be y equals to 9x minus 3. Any questions? Okay, then after that we need to find out what's the equation of the normal. So since we know the gradient of the tangent, the gradient of the normal will be the negative reciprocal of the gradient of the tangent. So that is -1/9. Okay. The normal will also lie in the same point, okay, that we have found in part A. So we will just use that point -1, -12 to find out what is the equation. So let me continue here. Okay, so you can leave your equation as y equals to -1/9x minus 12 and 1/9. Otherwise, you can actually leave it in integer coefficients, which means that that would actually be 9y equals to -x plus 109. Okay, sorry, minus 100. Okay. Any questions? So the routine that we're going through here, right, okay, it is similar to what we have done in chapter 6, points, lines, shapes. Just that we will be employing the help of the derivative to find out what is the gradient. Okay, rather than to use the gradient formula rise over run, right, to calculate the value. Okay. No questions. I would like you to try to. Okay, will you do try to now? That is found on page 374.
already.